Good morning, everybody. Welcome to another wonderful morning of chemistry with your host, me, Dr. White. All right, a couple things I want to mention. One, make sure you're doing the problem sets. Test number one is coming up. You're not going to learn chemistry the day before a test. You're not. I couldn't. You won't. Test number one has the highest average, so that means it's the easiest test of the semester. However, you still got to study. What's the best way to study? Do the practice problems. I'll say it again in slow motion. Do the practice problems. They will help you get a good grade. Now, one of the things I should be honest, in the past, all the times I've taught uh, either 1105 or 1211, like now, I've always with a double section had a Tuesday, Thursday lab. Now I have a Thursday, Friday, and I'm a little off sync. So I'm going to do something I normally will hopefully get back on sync for this Thursday and Friday. I'm going to finish today, most likely, chapter 4. Tests will be on chapters 1 through 4. And therefore, this Thursday and Friday, I will ask you, we'll go through problem set for chapter 3 and chapter 4. Oh, let me fix my finger there, chapter 4. And so be ready, do them. You got plenty of time. These are easy chapters. They're short problem sets, so you shouldn't have any problem. And we'll do that Thursday and Friday. Another thing I like to mention is on Wednesday, special announcement from the management, me, Dr. White. On Wednesday at the beginning of class, I will present what I don't have a good name for it. I just call it the method. It's a method to allow you to eliminate test anxiety like that. It works. I've been teaching it many years, and I will teach it the first 10 or 15 minutes on Wednesday. However, since one day I may try to sell it, I will remove it from the videotape that I will post for Wednesday's lecture. So if you want to learn about it, come to Wednesday's lecture. First beginning, I will do that. All right, anything more? Oh, one other thing. A favor to ask from Dr. White. On Thursday and Friday, I'm going to do an experiment to get to for you to know your colleagues better and for me to learn and get to know you better, which if we were face to face, I'd do this in a lab because I walk around the lab, talk to students. When I do a lab at COD, I don't sit behind a desk in great labs or go over the internet, search the internet. No, I walk around, talk to students, learn, get to meet you, you get to meet me. What I'm going to be doing this Thursday and Friday is, and I'll get to your question in a second, uh, I will be experimenting with you, yes, with you, breakout rooms. But I would like to ask, and I've never used them before on Zoom, tonight, if you have some free time, come to my office hours. If I can get a couple people to show up, even one, we'll experiment with breakout rooms before Thursday and Friday. If not, we'll experiment on Thursday and Friday. Thursday's group will be the true experiments. And then what I learned on Thursday, I'll do it Friday. And this is a chance for you to meet your classmates and know Dr. White. You might know me by now, but you'll be in a smaller group. All right, now, one of your colleagues just asked a question. That is, will you go over test one review that you posted? And should you do this on your own and use the time to ask? All right, if you look at the syllabus, I have next Monday in the syllabus, test number one review. And I post what I normally, in the past, I used to use that, do it on a whiteboard. And I'm thinking, why don't I post it too? So I'll go through it. And while I'm going through it, I will entertain any questions, as I always have. Remember, it hasn't changed. In my class, there's no such thing as a dumb question, ever, ever, and ever. I think everybody got that message. So, any questions before we get to some exciting chemistry? Dr. White's, I think, surviving junk food overdose. All right. Let's start out with a quick review, everybody. Remember the 3 states of matter. And whoever asking a question, hang in there. No, the test will be a week from this Wednesday. And on Wednesday, I'll talk more about the test so you understand what to expect. By the way, hopefully you've all handed in your lab and the signature sheet. I think just the majority, except for 1 or 2, have done the signature sheet out of 48. Thank you. And most of you, I think, have handed in the lab. I think you have until today or tomorrow. If I'll check the assignment area. I'll make it tomorrow just in case yesterday you were having a good time doing food, junk food overdose like Dr. White. Does that answer everybody's question? And Kelly, always feel free to ask questions, and everybody else. All right, let's go through everybody together. The 3 states of matter. The first one is solid. The second one, liquid. And if we were in class, I'd be asking you all to say this out loud. I'd say louder. And the last one, gas. That's louder. And remember, a solid has definite shape and definite volume. A liquid has definite volume but indefinite shape. And a gas has indefinite shape, indefinite volume. And you should know this. All right. Another thing I do in class are the 3 subatomic particles. If I spell particles wrong, someone laugh and let me know. But anyways, you should know these. Hint. And everybody together, the first one is electron. And you should know an electron has a negative charge, and we indicate that by a minus sign. Next one, proton. And a proton has a positive charge. And the last one, which I always spell wrong, I think I might have spelled it right, but I don't think so, is a neutron, and it has no charge. So the 3 subatomic particles, hint, you should know. Electron, proton, neutron. Notice I go into my official subatomic particle voice there. Oh, that's one I'll never say again. All right, just a little quick review. Let me look at any questions. The lab that was due on Thursday was the safety lab. This Thursday, if you have lab on Thursday, the density lab is due. And if you have lab on Friday, the density lab is due on Friday. I always give you a week to do the lab. Quick question. Ooh, let's do this. I'm going to go to gallery view. Quick thing, thumbs up, or maybe I'll use the poll. Hold on. Let's try this out. All right, let's try this. This is something new for Dr. White. So let's look at this. And I spelled it wrong. It should have been a question mark, not the greater than symbol. But everybody, right now, polling. Have you used Beyond Lab Z? I'll give you 20 seconds to, come on, everybody vote. This is wicked. It's working. Dr. White's really happy now. Everybody, come on. There's only 35, a couple more of you do it, unless you're on your phone. All right, let's do a second one. Look out, Dr. White's getting addicted to this polling. All right. First of all, I'll share the results. Most of you, a good part of you have done it. The other, make sure you do it. And nope, I don't want to do this. Again, I'm learning. Let's go down here. It is pretty cool, Kelly. Let me hang in there. I'm just learning new stuff as we're doing this. I'm gonna do one more. No, I still got to learn how to do this. Well, I'm going to have to practice later on. For those of you who did use it, let's try the old thumbs up method. For those of you who have used Lab Z, if you like this, give me a thumbs up emoji now. I'm seeing a lot of thumbs up. Good, thank you. All right. And I'm glad you told me that on, this is top secret, don't tell anybody, not really. On Friday, I had a nice meeting with the CEO of Beyond Lab Z, where I pitched that I can help him make it better. And he's quite interested. Right now, they're busy, very busy, which I can understand, with the beginning of semester, helping everybody who's using the product with problem get over those problems. And the last thing is they're porting over to HTML. So this way you don't have to download and have those things on your computer. And those of you who have Chrome computers won't have problems. Now, who asked the question? Let's see, Destiny, if you're having issues, come to my office hour or after lab on either Thursday or Friday, and I'll help you out. Dr. White's a power user on Beyond Lab Z now. All right, thank you. I'll have to practice more with polling. All right, let's get back to chemistry. And by the way, I'm up to date on YouTube. I'm a YouTube star. I have all the lectures of last week, and I'm posting both labs. So if you have Thursday lab, you can look at the Friday one, see if I'm cheating you. Or if you have Friday lab, you can look at the Thursday lab and see if I'm cheating you. I'm not. All right, let's get back to chemistry. Well, this was chemistry. Everybody see anion on your screen? Thank you. All right. We had talked about the periodic table. And we were talking about the periodic table, and let me open one up. Let me find one first. Today, my computer must be cold. It's slower than normal. All right, everybody see the periodic table, the green one on your screen? Blackboard, not Blackboard. Zoom tells me you should be able to see it. Now do you see it? All right, this is the one you'll use for every test. Notice it doesn't have the element names on there. You should have learned that by now. If not, hint, do it immediately this week. Now, let's look at some things we talked about already. Remember, the upper left-hand corner, the number there, the atomic number, tells you how many protons, how many electrons. If I look at my favorite, carbon, carbon has 6 electrons, 6 protons. Nitrogen, which is important, 7 electrons, 7 protons. Oxygen atoms are 8 electrons, 8 protons. If I ask you how many electrons bromine has, oops, you better know bromine, chemical symbol Br, which is right here, has 35 electrons. Now, another thing I talked about last week was certain columns, also known as families, have names. The first column, but not including hydrogen, is called the alkali metals. You should know this. And the only ones I'm asking you to learn are lithium, sodium, and potassium. There are others, but those are the ones I've asked you to learn. Next one, alkaline earth metals. Second column, alkaline earth metals. Magnesium and calcium are the only two I've asked. I like strontium, but you'll learn later on in the lab about that. And if I ask on a test, give an example and the chemical symbol of an alkaline earth metal. You could put down Ca calcium, Mg magnesium. If you know the other ones, that will work, but those are the only two. Now, if we go all the way over to the right, second column from the right, those are the halogens: fluorine, chlorine, bromine, iodine. You should know these are the halogens. And if I ask on a test, give an example of a halogen's chemical symbol. You could put down F, fluorine, or chlorine, or bromine, or iodine. And finally, the one that sometimes Dr. White remembers the old name, and those are the noble gases. Once in a while, and last week it did, it slips out, the inert gases, which they used to be called that till the 90s, until some very creative chemists found a way to make these react, really beat on it hard, very strenuous conditions that no one had ever tried. And he made them react, and we couldn't call them inert because they're not. So they were given the name noble gases. And if I ask, give an example of a noble gas and its chemical symbol, Argon, AR. Dr. White's worked with argon. When you do certain reactions, use that for an inert reaction atmosphere. I've done that. Kr is krypton. And as I've told you, in our universe, unless I've been hijacked to another universe, krypton is a colorless gas at room temperature, not a green solid that kills Superman. So, first column, alkali metals. Second column, alkaline earth metals, all the way over here. The halogens, second to last column on the right. And the very last column on the right are the noble gases. And you should know that. And we went through this. Remember, the atomic mass, I'm not going to ask you anything like that on test number 1. Oops, I gave away a secret. Oh, bad, Dr. White. But these other things you should know how to do, not only for test number 1, but for the whole semester. Just remember, you want to make Dr. White happy, and Dr. White gets happy when students do well on the test. So please make Dr. White happy a week from this Wednesday. Study, do the practice problem. Also, I think you want to do good too, I hope. I talked about a metal, and I'll skip this right now because we're doing a review. Ions, those are atoms, an atom with more or less electrons than protons. I'll teach you next chapter how to determine that. But there are 2 types of ions, cation, anion, you should know. A cation is positive charge because it has more protons than electrons, or another way of saying that, less electrons than protons. And that's where the word cathode, the positive side of a battery, comes from, cations. And anion is a negatively charged atom, and that has more electrons than protons. And anion is where the word anode came from. Now, I should have to be very honest. Dr. White loves cations, anions, and I've used them. They've been good to me. I've been good to them. All right, before we go into this one, I just remembered I forgot to teach you something that's not in a slide. Oh no. Well, guess what? I can fix that right now. Pay attention. This is very important. This is a chemical formula. Sometimes called the empirical formula. I'm not going to even bother misspelling it. Look it up. But anyways, and the chemical formula, I rarely use the term empirical, tells you a lot about a molecule. In case you don't know, this is water. In German, Wasser. In Hispanic languages, aqua. Dr. White's multilingual, sort of. And water in English. And you should know what this tells you is each one of these is a chemical symbol. So there's hydrogen and oxygen, and the number to the right of the chemical symbol, subscript, always subscript, tells you how many of that atom or element are in this molecule, water. And this has 2 hydrogens plus 1 oxygen, means there's 3 atoms in water. Oh, I better be subtle. whenever I was taking notes when I was an undergrad. I think I started this in high school. It was important. I started putting stars. It was very important. You better know this. I also added in the left margin IMP, and I'm doing it now. Some of you might say it's common sense. Ooh, time to teach you a life lesson. It's a life lesson time, and you're not going to even have to pay extra for it. And I was lucky enough to have some great mentors in my life. And one of the greatest was Sid Shapiro. Unfortunately, Sid is no longer with us. God rest his soul. He died in '95. But when I started in industry, he was in his late 60s. I was in my late 20s. And he became my mentor. We actually carpooled, and he quizzed me and taught me a lot. One of the most important things Sid taught me was common sense is not common. It's not. And I've solved some major problems when people look at it and say, it wasn't hard. You should have used common sense. I said, I did, but most people don't. So remember, common sense is not common. And that ends today's life lesson from Dr. White. Now let's get back to chemistry. Now, another molecule you know is table salt. Otherwise known as sodium chloride, if I can spell it. See what happens to my spelling when I'm suffering from junk food overdose? It goes downhill. And this has, you should know, 1 sodium and 1 chlorine. Therefore, it has 2 atoms. And you should be able to do that. 1 + 1 = 2. Oh, by the way, if you ever go out to dinner with a chemist like me, and I've done this, we'll ask, please pass the knuckle. Now, let's look at another one. It's brutally cold outside, and rock salt, sodium chloride, will not melt ice. But if you live in a community, and most of us do, who put out stuff on the street to melt the ice, they've been putting out, now that we're down in the single digits, this molecule. Calcium chloride. And this is those little white pellets you can buy in the home improvement stores. Dr. White has a 50-pound bag fresh in my garage for emergencies, which I might do tonight. And I would ask you, your turn, I'm going to let you have some fun. How many atoms are in calcium chloride? Go.
Maybe 3.
When you're done, give me a thumbs up. Oh, I see even fingers, people doing fingers. See, I really am suffering from junk food overdose. All right, let's do it. It has 1 calcium. How many chlorine? Subscript 2, 2. 1 + 2 = 3. Now, I need to teach you about something else using parentheses, but first I'll check and see if there are any questions. Kelly, that's due to the fact that there's nomenclature, which I'll talk about, I think I'll get to today, but I won't be asking you to learn. There's official rules. The elements are called like chlorine, bromine, but when they're in certain molecules, we drop the INE ending in chlorine and replace it as an IDE, chloride. And this is mainly because, and I'll teach you this later on, chapter 5 or I think 10, that this is actually an ion, not the actual element in this molecule. everything you wanted to learn about calcium chloride and are afraid to ask. Dr. White knows his chemistry, which is a good thing. All right, now let's look at a certain molecule. And this is calcium hydroxide. And I'm not going to ask you this semester in my class or any time this semester to learn chemical names other than water and sodium chloride, NaCl, but I'll teach you, I'll use the names myself. And somebody's getting ahead of me. When this is called, and I'll teach you next chapter, or the end of this chapter, or next chapter, a polyatomic ion. And when you see these brackets, whatever is inside, you multiply by the subscript to the right outside the bracket. So here I have 1 calcium, but inside the bracket I have 1 oxygen, but I multiply it times the 2, so there are actually 2 oxygen in there. And I have 1 hydrogen here, but I multiply it by the 2, and I have 2 hydrogen, and therefore we have 5 atoms in calcium hydroxide, otherwise I believe called lime. That's an ancient name. And let me have you try one. I don't know if this molecule exists, magnesium bicarbonate, but how many atoms are in magnesium bicarbonate? Your turn, Dr.
Is that a 2 or a 3 at the end of the oxygen? Dr. White?
Dr. White, at the end of the oxygen, is that a 2 or a 3?
And when you're done, give me a thumbs up or smile, or do both. I'll give everybody time to do this. That's Mg bracket HCO subscript 3 close bracket subscript 2. All right, anybody need more time? I think not. Let's do it. All right, question is how many atoms? Ooh, I could do something like this in the future. Or I could even make it 2 points if I'm in a generous mood. And how do we do this? I have 1 magnesium. Oh, I have 1 hydrogen, but you multiply times the number to the subscript right of the bracket it's in. So that makes 2 hydrogens. I have 1 carbon here, but again, the subscript 2 here. So I have 2 hydrogens. Ooh, I have 3 oxygen. Multiply times this is 6. 1, 2, 2, 6. And therefore, if I do my math correctly, and hopefully I do, that's 11. That I added up, 2 times 3 is 6, 2, 2, 5 plus 7, 11. So there are 11 atoms in magnesium. Oh, let's do another one. These are fun. This is sodium sulfate, Na2SO4. How many atoms in sodium sulfate? I see everybody already jumping in on chat. If you want to, go right ahead. If you don't, guess what? Don't. I think everybody's done ciphering. Ooh, I just did a big generation gap on you. For those who used to watch the Beverly Hillbillies, like when I was a kid, one of the actors or people on the show was called Jethro, characters in the show. And Jethro was about 25 and didn't do math too well. Whenever he did math, he called ciphering. But anyways, let's do the math. All right, how many atoms in sodium sulfate? 2 sodium, 1 sulfur, 4 oxygen, and that's the number 7. So there's 7 atoms in sodium sulfate. By the way, sodium sulfate, how many of you ever bought something like electronics or optical stuff like a telescope or binoculars? I no longer have my telescope, but I still have my binoculars. And you see those little packets of stuff that say, do not eat. And they contain that molecule, sodium sulfate, and that absorbs moisture. I'll talk about that, how it does it another day. And that's sodium sulfate. And don't eat the packets. Oh, by the way, about 2 years ago, in equivalent to 1211 at the other school, I had a student raise her hand and say, oh, I used to eat those when I was young. Oh, she was a good student, but she had a wild childhood, I bet. All right, let's move on. Now, the next couple of slides, click. Normally I do this, click, but since we're on the small screen, not in a classroom, I'll use click. The switches in the off position, will this be on a test or a final, but still important background information that we'll use during the semester, some of it. All right, when we talk about molecules, one important thing is its weight, which we call for elements, the atomic mass. And atomic mass is determined by something called isotopes of an element. Again, switches off. And an isotope are atoms of the same element that have different number of neutrons. They have the same electrons and protons, but different amounts of neutrons. So this won't ever be on a test, but an isotope is atomic atoms of an element, same number of electrons and protons, but different number of neutrons. If you go back, I think I spelled neutrons wrong. I always do. All right, this is called the nuclear symbol, and you might use it in other classes. We'll never use it. I have never used it in my professional career, and it goes back more than a couple of months, a lot more. But it's written, you have a chemical symbol, and then the mass number is on top. The atomic number called Z is below, and I've never used it in my whole career going back, well, I got my first US patent in '84. I already had my PhD. And I go back before that. Well, I'm still alive and kicking. Well, I don't kick anybody, but anyways, I'm still here and I've never used that. So that's why I have the switch off. All right, now, this is an important concept that you should understand, and that's called the atomic mass number of an element. I'll never put this on a test, but the atomic mass number of an atom, of an element, is the number of protons plus neutrons. Now, if we look at carbon, and we're talking about each isotope, I don't write the word isotope that often. And that's the sum of the number of protons. So carbon, the most abundant isotope, has 6 protons, which carbon has, and 6 neutrons, which equals 12. And I think you might have heard of carbon 12, and that's talking about this isotope, which has this atomic mass number. Now that's important. It's called the atomic mass number. Now, we use, and you'll be using this a lot in my class, what we call the atomic mass. And the atomic mass, by definition, remember, switches off, is the weighted average mass of all naturally occurring isotopes of the element based on the abundance, fancy word for how much, and the mass of each element, isotope, on our planet. Thumbs up, people. You see the periodic table? Thank you. Now, if you look at the periodic table, let's look at my favorite, carbon. And you'll see the atomic number is 6. Now, the number underneath is called the atomic mass, not mass number, the atomic mass. If you notice for this periodic table, you have 12.011. And what that does is it takes a mass weighted average of all the isotopes. There's carbon 12 isotope. There's also carbon 13 and carbon 14. How many of you have ever heard of carbon dating that scientists use to determine how old is this dinosaur bone? And that looks at, I believe, carbon 13, which slowly changes into carbon 12. And by knowing how much carbon 13 is in a sample, they can determine the age of it. But there's not much carbon 13. Most abundant isotope of carbon is 12. So that's why the number is very close to 12. Same thing for oxygen. The most abundant isotope is 16. 8 protons, 8 neutrons, but there are other isotopes, but that's why this is 15.99. In this class, I'll ask you to know that the number underneath is called the atomic mass. Now, why did I turn the switch off for atomic mass number calculations? Because guess what? In my whole career, I've never done that except one time, and that was freshman year college. The teacher put on a test. There's so many of this isotope and so many of that. What's the atomic mass? And you do a weight average. Guess what? I've never done it since then. You'll never do it. I know some instructors like to do it. Why? You look it up on a periodic table. Dr. White lives in the real world. If I haven't done it, why am I going to ask you to do something I've never done? And most chemists never do. They look on the periodic table and get the atomic mass. That you should know. Boy, I just looked at my clock. Time flies when you're having fun with chemistry with Dr. White. I hope. Oh no, look what happened. We're at the end of chapter 4. And that means I've kept my promise, which I always try and do. I usually do. And that is, I will always, or at least try, and I usually do, finish material on a test at least a week before the test. That will give you time to study. And that way my students get good grades. Remember, do the practice problems. Do the practice problem. Do the practice problem, please. Please. Thank you. All right. So I have covered everything on test number 1. This will happen during the semester. Before the next test, I'll start material on the following test in lecture. This will not be on test number 1. It will be on test number 2, so you should pay attention. All right, quick public service announcement in case you came in late. Don't forget, on hand in your lab by tomorrow, that's the density lab, or you'll get 0 points. I graded most of your, or I should say, bad doctor, hand in the safety lab. I've graded most of yours. Sometime tomorrow, I'll post the scores for your safety lab. Most of you got a 10 or 9, most of you. Also one in lab, but I'll say it now, and that is anytime I hand back something, unfortunately with this, I don't give you the actually paper back where I put marks on it. I'll just give you a score. Always feel free to ask me after lab or my office hours, why did I get the score? Because in my class, there's no such thing as a dumb question. If you want to know why I took off points, always feel free to ask. And that's always true. I see a question. The density lab, which you did Thursday or Friday, is due this Thursday or Friday. Ooh, how'd you like the fancy if you did Thursday or Friday? Junk food overdose. I can blame it on that. But anyways, the density lab, if you have lab on Thursday, is due Thursday. The density lab, if you have lab on Friday, is due on Friday. And if I look at my clock over here, it's time to take a 5-minute break. Come back at 10:55. Dr. White's going to stretch. I need to after sitting all this time. I'll see you in 5 minutes. All right. Better call you all back to class with something I haven't used too much this semester. Time to start class again. I love them. Unfortunately, the company that makes this went out of business a while ago. I only have a couple and they don't leave my house. They're treasured. All right. For those of you who came in late, quick public service announcement from your host, me, Dr. White. This Wednesday, the beginning of lecture, I will do my famous, the method, teach the method. This is a way of eliminating test anxiety. It works real well. I will remove it from the video because I don't want it in the universe of YouTube forever and ever, because I might try and sell it some year. All right, Marissa, you don't forget you can watch me on the video, instant replay on YouTube. And life happens. Luckily, I have my, how should I say, my videos posted. So if you ever do have to leave for whatever reason, and now with the virus, a lot of reasons pop up, feel free to. I understand that life happens. All right, but don't forget the first 10, 15 minutes on Wednesday, I will be teaching you the method, and it works quite well. It's worked as young as I've had people who've asked me to help them. For 8 and 9-year-olds, it works. It is amazing. All right. It's time for a new chapter. That's chapter 5. And this material will not be on test 1, but it will be on test 2. And like I said earlier, I will sometimes finish early before a test and move on to the material on the next test. And today's an example of that. All right, thumbs up, people. Everybody see chapter 5? Thank you. All right, this chapter, we're really going to get in some good chemistry. And we're going to talk about molecules and compounds, which Dr. White uses those interchangeably. Now, I've already mentioned it. This will be for test 1, but I thought I'd go through it. Chemical formula, that's the notation made up of chemical symbols presented in a compound or a molecule, and numeric subscripts located to the right of the symbol indicate. I see a question, so I'll stop. Oh, maybe I made a mistake. Hold on, once in a while I do. Dr. White, let's look at. Bear with me. You're right, Dr. White just made a mistake. So and thank you for catching me. Oh, Dr. White, remember I told you I don't walk on water unless it's, so you'll just have to wait for chapter 5, and let's get into chapter 9. One of the things, And really, I should have known better. Bad Dr. White. I was rushing this morning and made a mistake. All right, one of the things, the book, how many of you bought the book? If you didn't buy the book, give me a thumbs up. Aren't you glad I told you not to buy the book? One of the things I do is I follow the different chapters in the book in terms of the material in there. If you were actually using the book, and since Dr. White knows how to teach chemistry, I jump around. The way it was organized, the book they have for this class, I disagree with the author. And I'm teaching it, so I'll do it my way. All right, let's now do the right chapter. And we're going to do chapter 9. Now, if I look at the syllabus, which I just got rid of, and let me do this. I look at the syllabus, the chapters on the test will still be 1, 2, 3, and 4. That I got right. See, I told you I'm suffering from junk food overdose. I can blame it on that. All right, let's do chapter 9, which is also a lot of fun. And let's talk about the electrons in an atom and the periodic table. Now, as I mentioned earlier, in the nucleus, the center of the atom of any element, we have, and you should know, protons and neutrons. So in the center, in Rutherford's gold foil experiment, hint you should know, taught us that the nucleus, center of the atom, is dense and contains protons, neutrons. So the question is, where are the electrons? Good question, thank you. And that's what you'll learn this chapter. Now, in order to teach you where are the electrons, there's a couple things I need to go over. Now, next couple slides, the switch, will this be on a test in the off position, but I still like to talk about this. And one of them is electromagnetic radiation. Switch is off, but that's energy that travels as waves through space. The light you see is electromagnetic radiation. The microwave oven uses electromagnetic radiation. Your cell phone is connected to the cell phone towers by electromagnetic radiation. Now, when we talk about this, there are two important things: wavelength and frequency. And electromagnetic radiation is like ocean waves. It has wavelength, which we use the Greek letter lambda, and frequency, how quickly they come into shore, the Greek letter nu. Now, if you were taking physics or advanced 2 semester, nu is C over lambda. Ooh, time for Dr. White. Personal story. I went to IIT, which is Illinois Institute of Technology. When I went, I don't know how is it now, it was a top school, got me into grad school at Northwestern, U of C. I went to Michigan State and a couple others. And if you were walking around campus, and 90% of the campus when I went were all STEM majors, mainly science and engineering, not even STEM, the science and engineering. And one of my fraternity brothers or I would ask someone else, what's new? And knowing the formula I just gave you, the correct answer was C over lambda. Science joke there. And you're free to use it anytime. C, what's new? C over lambda. But anyways, this is a dependency, and C is the speed of light, which is a constant. Now, the magnetic energy is over what we call the magnetic energy spectrum. This is the arrangement of all forms, switches to law, of various electromagnetic energy in order of decreasing energy. Hang in there, Dr. White's out in the internet. So everybody see the electromagnetic spectrum? Thank you. And here's one representation. There are others. And it goes from gamma rays, the ones that turn Dr. Banner into the Hulk, X-rays, and these are the most energetic, ultraviolet, which will give you skin cancer. And then we have visible light right here. For those who remember Roy G. Biv, which helps remember the different colors in the spectrum. Here's red, here's blue at the lower. Then we go a little lower energy, infrared, then microwaves and radio waves. And those all are electromagnetic energy. And think of things like light as having energy. And as I just mentioned, the photons, or should be really photons, are packets of energy of light, different types of electromagnetic radiation, like I said, gamma, visible, UV, X-ray, microwave, and radio wave. And this will never be on the test or the final. Now, when we talk about chemistry and atoms of elements, there's something called the atomic spectra. This is when light is emitted from heated elements as they pass through a prism. And the prism breaks the light into various colors, separates them. And this is called the atomic spectrum. Everybody see the prism on their screen now? Up. Aren't you? Now do you see it? Thank you. And this is an example of how you do atomic spectra. You heat up an element, in this case, hydrogen. They have a slit to cut down the amount of light. It goes through a prism, and you see various colors that make up the overall color or light emitted, also known as the atomic spectra, in this case for hydrogen. And notice here, you'd only see right here, essentially 4 lines, 2 you can barely make out, and the one at 656.3 you can make out pretty good. And all elements have this. Here they show for iron all these. For helium, you can barely see it. And these are atomic spectra. How many of you ever seen the show on like CSI where they have a certain sample and they say, well, it's got so much iron and so much of this and that. And they're doing atomic spectra, and there's a name for it I can't think of right now, elemental analysis using atomic spectra to identify elements in a sample. There are other ways of analyzing samples too, but that's mainly organic chemistry, which I don't teach, unfortunately, this class. Got to take my, well, I don't teach organic here at COD, but I do teach it at ECC, that's 170. But anyways, when you heat up something, an element, it gives off light. How many of you ever seen neon lights? And that's the neon or other inert gas, I used the wrong term, noble gases being heated up. How many of you have been in Chicago? They don't use them that much out in the suburbs. You see the street lights that give off that yellowish color? Those are called halogen lights. Or have you ever been driving around at night and the other person has those super bright lights at you, which I don't like? Well, I guess if I had them, I wouldn't care, but I don't. And those are halogen headlights because you're heating up halogen to give off certain colors of light that form that from that type of element. And each one of those colors corresponds to a certain amount of energy. And that's very important because it helps us learn where are the electrons. Now, I'm going to skip this, just really quickly go through this real quick. The Bohr model, electrons travel around the nucleus at fixed distance. They're called orbitals, like steps of a ladder, and energy between each orbit is fixed and called quantum energy, switches off, and electrons go from higher orbit to lower orbit. And when they go from higher to lower, give off photons. I'll talk more about this light. Now, one of the things that I just mentioned is, if you've ever seen fireworks display, and when I was, a long time ago, when I was younger, friends of mine, myself, we used to go to Chicago and watch the 4th of July fireworks. If you haven't figured out, Dr. White is about 6 foot, unless I shrank in the last week. And I work out with weights, and my friends were big too. So when we go down, we've always got good spots by the lake. That's before they did the concert too, which I didn't like. Just give me fireworks. And when you see those fireworks, those are electrons going from one orbit, or we'll learn later on, shell, to another one. They're heated up by the explosion, and there's stuff in the fireworks that when it goes away from the explosion, it cools down and gives off light. Because it was at a higher orbital, now it goes to a lower one. When it does, whoop, it gives off the light. And we'll be doing a lab like this soon, where you'll see how different elements, when you heat them up and they go out of the heat, give off light. How many of you have ever seen things you put in the fireplaces to make them different colors? Same thing, you're moving electrons. See, chemistry's everywhere. And by the way, the fancy name for what I'm sort of going over, but not in detail, is quantum mechanics. And in grad school, that was one of the more difficult courses I had to take, quantum mechanics. When you take it in grad school and as a PhD candidate, use high-level math like partial differential equations, and it's a lot of fun. Well, not really, but it's important to learn. I'm an organic chemist. If I were a quantum mechanic chemist, I'd be smiling now more. Now, the different energy levels are associated, in an atom of an element are associated with lines of the atomic spectrum, which shows changes in energy level of where the electrons are. This is where the electrons are. They're around the nucleus. Now, these energy levels are quantum numbers, and I'll talk more about this, which is still off, which are called 1, 2, and 3. And these energy levels are called shells. Again, switch is off. Look out. Gotta get your attention. All right, switch is on. I love that whistle. By the way,
Dr. White.
Personal life advice, never let the little kid inside of you disappear. Always keeping the 5-year-old who's still inside Dr. White and has fun doing. Love it. You got to suffer through it, but I'm in charge. All right. Time for Dr. White to be subtle. And this pertains to the next couple of slides. All right, first of all, nucleus. You should know, first of all, you should know that I didn't switch over. You couldn't see it. All right. Thumbs up, people. Do you see nucleus on your? All right. All right. Again, I'll be subtle. Hint, know this. All right. When we talk about subatomic particles, we're the protons, neutrons, and the electrons. You should know that oh, I know what you're right, not mute on. I forgot to turn my speakers on. Thank you. All right, I can blame it on junk food overdose today. Does everybody see nucleus on your screen? Somebody turn on your mic and say something.
We could see on the
I
screen.
see it.
All right, I said say something, you should have said something.
Something, yeah.
Dr. White's now being silly, which I can do. Thank you. All right. Nucleus, let's get serious. Nucleus, you should know. That's very small, dense center of the atom, and it contains the protons and the neutrons. I always forget, is it E or U goes first? One of the two. But anyways, you should know that. And around the nucleus, we have the electron cloud. And the electron cloud is the area where the electrons of an atom are. So you have a small dense center, and then around it are the electrons. Why do they call it a cloud? Because if you've ever been up fly through a cloud, you know it's very spread out water molecules like cotton candy. Well, that's not the same. But anyways, if I had an atom of an element in my hand right now and was the size of a grapefruit, the electron cloud would go 1.5 miles that way and 1.5 miles that way, have a 3-mile diameter. It's spread out when the nucleus is only this big. And that's why we call it the electron cloud, because most of it is empty space. Oh, I was awful little on my 2.5 to 3 mile diameter. Well, here I used a baseball instead of a grapefruit. That's why. All right. Let's talk about where are the electrons? How are they arranged in atoms? The first thing, we have an electron shell. And the shell is a region of space around the nucleus that contains electrons approximately the same energy and spend most of their time approximately the same distance from the nucleus. Again, you have the electron shell where electrons have approximately the same energy and are approximately the same distance from the nucleus. Now, most people make the mistake that they think of an atom like the solar system. The sun is like the nucleus and electrons are moving around like the planets. It's not that way. It's still the nucleus is the center, but the electrons are just around it, approximately the same distance. They don't have specific orbits like the planets. They vary a little, which makes life happen, which is a good thing. Now, in each shell, electron shell, we have the subshell, electron subshell. And a subshell is a region of space within an electron shell that contains electrons that have the same energy, and I don't have it here, that are the same distance from the nucleus. So each shell has subshells. Say Sally has these shells, never mind. But anyways, each shell, electron shell, has subshells, electron subshells. And in a subshell, each electron has the same energy and is the same distance from the nucleus. Nucleus, center of the atom. Remember, this stuff will be on test 2, not test 1. Now, I'm going to turn the switch off for these slides. We also have another way of looking at it called orbitals. That's a region in the atom where electrons have the highest probability of finding an electron. What is really an orbital? Let's assume, it would be nice if I had the power to stop all motion. I was all powerful, which I'm not, but if I did, and I pushed the button, stop, everything would stop, including the electrons moved in the molecules in the atoms of everything. And when you stopped everything, you said, here's the nucleus, where would be an electron in a certain shell and subshell, the orbital would give you the area of the probability where you'd find the highest probability of that electron. Good news, we're not going to get into orbitals in this class. Thank you, Dr. White. You're welcome. Don't tell everybody I'm being nice. Switch is back on. See how subtle Dr. White can be? I really should say know how to use this, but I'm shorthand. When we have our electron shells, they have very hard names to remember. There's shell 1, shell 2, shell 3, and shell 4. In test number 2, this table, I will give to you important information. I used to make students memorize it. Now I just will ask you to know how to use this information. Now, each shell has subshells. Shell 1 has 1 subshell in it. Shell 2 has 2 subshells, 3 subshells, and 4 subshells. So, how many subshells does shell 2 have? 2. How many subshells does shell 1 have? 1. Now, this is not on the table, but you should know the shells are ordered and named in lowest to highest. Shell 1 is the lowest energy. Shell 2 is the next lowest. Then 3 on this table, 4 is the highest. So again, each shell is called by its number. Aren't those hard names? And you should know, at least know how to use this table that shell 1 has the lowest energy, shell 4 is the highest. Shell 1 has 1 subshell, shell 2 has 2 subshells. Ooh, it's a tongue twister. Shell 3 has 3 subshells, and shell 4 has 4 subshells. Now, the electrons are located in the shells, but they're really in the subshells of the shells. Says orbital designations, but these are also known as the subshells. And they're given letters, and they are S, P, D, and F. There are only 4 subshells, and that is S, P, D, and F. Now, S is the lowest energy orbital or subshell. And F is the highest energy subshell of any shell. So the subshells have names or letters S, P, D, and F. And a while back, I've forgotten this. And again, this is lowest energy to highest energy. And this is the less than. 3 lines means defined or exactly. The math symbol less than. Example, 2 is less than 6. Therefore, S has less energy than P, which has less energy than D, and F, which is essentially what I'm telling you. S is lowest, F is highest. Now, I won't ask you this, switches off for this, and that is those letters have names. A couple of years ago, a student asked me, and I put it in the slide. They come from the electromagnetic spectra, or energy spectrum of elements. And the S is for sharp, meaning it was a sharp line. P is a principal, D is diffuse, F is fundamental. How they got that, I don't know. That's not the area of chemistry I practice, but I do know those. So what does this mean? It means I have to change pen colors. And really, I should change this. Orbital is also known as a subshell. And what this means is subshell S has a maximum of 2 electrons. Whether it's 1s, 2s, 3s, or 4s, you can only put 2 electrons in there. P, you can put maximum number of electrons is 6. D, you can put 10, and F, you can put 14. And you should know how to use this chart, and I'll be teaching you that either today or on Wednesday. Now, in the past, I made students memorize this chart. Number of electrons in each subshell will be an important information test number 2. And as I mentioned earlier, this table if we're in a classroom, this would be on the whiteboard because we're going to need to use this. S is the lowest, and as you go down the table, you increase the energy of each subshell, which is located in each shell, and S is the lowest, F is the highest energy. Remember, S only has 2 electrons maximum, P 6, D 10, F 14. Again, good news. You can all smile now. You no longer have to memorize this. I will give this to you on the test. The last page or two of every test and the final will have important information because Dr. White has decided about a 1.5 years ago, do I teach chemistry or do I test, or I should say, do I test how well you've learned chemistry or how well your memory is? I'm a chemist, not a psychologist or psychiatrist, so I'm not doing memory. And I give you this now. Thank you, Dr. White. You're welcome. Now, what does this all mean? Oh, one other thing, switches off for this. When we talk about orbitals, electrons have spins. Electron has a negative charge. So when it spins, it has a magnetic field and has a charge. And therefore, electrons spin clockwise or counterclockwise. And you can only put 2 orbitals into electron. And subshells have different orbitals, a number of them, which I'm not going to get into. However, the electron spin, I will mention, I talk more about this in organic chemistry. How many of you are familiar with imaging in a hospital? Nuclear magnetic res imaging, or what's the right name they call that? They just call it nuclear magnetic energy, or what are they, imaging, or what do they call it? Anybody? MR, magnetic resonance imaging. And that comes from organic chemistry, who found out by putting a radio field and a magnetic field, you can tell when you flip the spin on an electron. In hydrogen, you can also do it on carbon. And organic chemists use that to determine the structure of molecules. Well, it turns out years later, someone got very smart and found out you could do that to the whole body and use a computer to process that information and give you things. So next time you think about MRI, you're flipping electrons due to the spin, which way they spin, clockwise or counterclockwise. Thank you for all who let me know about that. Again, switches off, shapes of orbitals. S is spherical. P orbital looks like an hourglass. If you stopped energy anywhere inside this hourglass, which is really 3-dimensional, is where you'd find the p orbitals. I won't teach in this class. How many of you heard of cis and trans fats are bad for you? Or cis is good, trans is bad? That's due to p orbitals between 2 carbons in the fat molecules. So this stuff plays a role in our daily life. That I teach in organic chemistry. I won't be teaching here. Won't be on a test. And other orbitals have others. Now, electron subshells are filled in increased, switches on again, are filled in increasing order energy. You always start at the lowest level, subshell and shell. This is called the Aufbau principle for building. And electrons occupy the subshells in each one, so they acquire 1 electron before the other. This I won't be asking you to learn. And this, no more than 2 electrons can exist in an orbital. They must have opposite spin. Switches off for this slide. That's called the Pauli exclusion principle, also known as the bus seat rule, which I won't teach in this class. However, switch has just been turned on. If I had a dial and it only went to 10, I've just turned it to 20. I stole that from the movie Spinal Tap. If you haven't seen that, it's a really weird movie. It's a cult film. Everybody get the message? Am I being subtle enough? Know this. And this we're dealing with, we're talking about the electron configuration. And the question is, if the protons and neutrons are in the center, in the nucleus, where are the electrons? And the electrons, where they are, you use what's called electron configuration. Think of this as an accounting method to show where are the electrons. And it's a statement of how many electrons an atom has in each of its subshells. And it uses hint, numbers, and letters only. See board, for example. Well, I better get to work. Actually, you know what? Yeah, let's take a look at something real. Let me remind you, in order to do the electron configuration, you need to know the shells. Shell 1 is the lowest energy. Shell 2, next lowest, then 3, then 4. You need to know shell 1 has 1 subshell. Shell 2 has 2 subshells, and 3 subshells, and 4 subshells. Now, you also need to know that the subshells have letters S, P, D, and F. The lowest energy subshell is S, then P, then D, then F. You always fill the lowest energy shell and subshell before you fill the higher ones. And subshell S, you can only put 2 electrons max in, P 6, D 10, F 14. And this chart and the previous one, I will give you. In the past, I would make you memorize this. Now I won't. And it's time for, oh, I get to do a cliffhanger just like on TV. Tune in on Wednesday morning, this Wednesday morning, and you'll find out how to do electron configuration. How do you like that cliffhanger? Just like in TV, will the heroine get saved by the hero? Well, you got to tune in on Wednesday. In this case, all right, couple quick things. Remember, if you came in late, I've finished everything for test 1, and I hate to do this, but I will. And there's not a lot of info. It's not that hard. This Thursday and Friday, I'll be doing both problem sets from chapter 3, chapter 4. Chapter 4, chapter 3. Make sure you do them before I do. That'll help you get a better grade. And remember, if you have any questions, do it. Also, don't forget, on today or tomorrow at the latest, hand in the safety lab. You should have gotten in, most of you have. Try and do it by tomorrow, otherwise you'll get a 0, and that's an easy 10 points. Most of you got 9 or 10 or 9 points, which is still an A. Also, don't forget this Thursday and Friday, the density lab is due. Also, when you hand in a lab, is through the assignment area as a PDF file, which most of you did on the safety lab. Thank you. And instead of rushing through electron configuration, which wouldn't be fair to you, I'm going to say, I'm going to end a couple minutes early. Don't tell anybody. Shh. With that, I'm going to say, Gang Gesund. Oh, I forgot before I Gang Gesund, I'll take that back. If you have a chance tonight, come to my office hours. I'm looking for volunteers, where I'm going to practice with you people who show up for volunteers how to use the breakout rooms. And if nobody does, we'll experiment on Thursday and Friday. And with that, have a great day. Stay warm and Gang Gesund. Bye now. Ooh, I can even do this.